right, everybody, welcome to the Daily Space Weather, and we've got a lot of activity going on here. High likelihood of solar flares, coronal mass ejection warning back on. We've got 3 beta-class sunspot groups. Check out the flaring that we've caught here. And what you're looking at here is SDO imagery, the Solar Dynamics Observatory, in ionized helium and ionized iron. So we'll be talking about chemical abundances sort of in the middle of the video. Should be another interesting one. Lots of stuff to cover. Also, if you didn't check our meteorology segment, make sure you check that out. Here's a colorized magnetogram from the SDO, and you can see sunspot 2860. The fields are still spreading apart here. This increases the likelihood of major flares. It's also grown some additional umbrae. Sunspot 2859 has grown as well. It's now a very powerful beta class. Well, it's not a super powerful beta class sunspot, but it is now a legit beta class sunspot. Let's just say that. The most likely place for a major flare is sunspot 2860. Also, sunspot 2861 up here has now become a beta class sunspot as well. So lots of chances out there for major flares, M-class flares, etc. The good news is that these large sunspots here are moving into the Earth-facing zone. And so if they stay stable when they get to the other side of the sun, that'll be a higher likelihood of major flares, as there is an Earth-facing quiet effect that is rather hotly debated even to this day among heliophysicists. So here is the 335 plus helium. So it's ionized iron and 335 angstroms ultraviolet light, and ionized helium and 304 angstroms ionized light. And we keep showing 304 angstroms here because of its ability to show filaments. So speaking of filaments, we actually have an eruption here. This is the El Teide ground-based observatory, and you can see a filament eruption right here. Keep in mind this data is 23 minutes old. At least the last frames are. That's part of the Gong 2 data, the National Sunspot Observatory. Here's another wavelength. This is 211 and 304. And I would note this sort of coronal hole region right around the equator of the sun there. That's an indication that the solar cycles are progressing. And this explosion-like situation here did indeed cause a coronal mass ejection. It was very diffuse, and we may see a pulse from that in about 2 days here, as that was a high-speed coronal mass ejection, but it was very diffuse. So if we see a signal, it'll be a fleeting signal of high-speed protons. Also, we've got a coronal mass ejection currently striking the geospace. We'll get to that in a minute also. First, a 10.7 centimeter radio flux has come up to 89, so the most proportional data set to sunspot number, increasing with the sunspot number as you would expect, approaching the 90 mark here. So moving back into the higher levels of activity, thank goodness, is El Sol. Here's the Space Weather Enthusiast dashboard, and you can see we've got some geomagnetic unrest forecast for later in the day today and early in the day tomorrow on August 28th. Here's the Stereo A space weather beacon located at Lagrangian point 5. And for you new viewers out there, congratulations on realizing our channel exists. Lagrangian point 5 is an equilibrium gravitational point where you can put a spacecraft and it'll chase the Earth as it orbits the sun without much use of fuel, the location of Stereo A. So here's a diagram of that. Stereo A located at L5. And we'll be watching this throughout the day as there is a coronal mass ejection warning still in place, as well as a watch for major solar flares. So let's take a break from this and look at seismicity for a moment. Here's the 90-day bar graph from volcanodiscovery.com. We saw an ice quake here in the northern foothills of the Alaska Range. That was a 2.7 magnitude ice quake. Apparently it's because glaciers are collapsing because of your SUV, and we're all going to die because of alleged global warming. So just on that note, let's take a quick moment to talk about a negative feedback mechanism. When the planet warms, what happens is Greenland injects fresh water into the AMOC, which causes the AMOC to be cut off. When the AMOC gets cut off, England freezes, and then the rest of Europe follows suit. According to the geologic record, that's the way it works. Guess what happened last year, folks? The Thames froze. Were you aware that the Thames froze last year in 2020 in like March or February. Yeah, the Thames froze. Talk about a canary in a coal mine. I remember in 1987 coming home from school and telling my parents that global warming leads to global colding, as there's a negative feedback mechanism associated with fresh water from Greenland being injected into the North Atlantic. Let's continue on here to go back to seismicity. Philippines saw a deep quake at 4.7, but we're still seeing quakes here at the South Sandwich Islands. It looks like a little bit fewer than the past few days. A solid week there of crazy activity at the South Sandwich Islands near the tri-boundary of the South Pacific, Antarctic, and South Atlantic plates. Continuing up the list here, nothing too exciting. Japan saw a 5.0. Fiji Island saw an extremely deep 4.8 magnitude quake at over 550 kilometers depth. Indonesia saw a 4.5. That was at 157 kilometers depth. Timor-Leste saw a 4.6 at 144 kilometers. Nevada saw a quake 1.9 kilometers above sea level at a 4.6 magnitude. That's interesting. Also a 2.8 looks like an aftershock there at Nevada. Leave us a comment if you felt any of those quakes. Leave us a comment if you've ever felt a quake. I've never actually confirmed felt a quake despite being in a few. Let's look at volcanoes. While we're on the earthly segment of the daily space weather, Kamchatka features some volcanoes, and Karimsky is now exploding and producing a 10,000-foot plume of volcanic ash. Suwanosejima in the Ryukyu Islands south of the Kamchatka Peninsula, producing about a 9,000-foot volcanic ash plume as it explodes Vulcanian style. Also producing pyroclastic bombs and blocks ejected up to 400 meters away from the crater don't hang around. Volcanoes that do such things. Mount Ibu, flight level 060. Ibu, rather, flight level 060. It's a 6,000-foot ash plume. Tokono exploding, 7,000-foot ash plume there. Samisa-Pochnoi in the Aleutian Islands. No report provided by the Volcanic Ash Advisory Center, Washington. I couldn't imagine anybody being incompetent at their jobs, as, after all, 2021 supposed to be the year of accountability, not the year of incompetence, right? Fuego has dispersed its ash. Revenador exploding, producing a 15,000-foot ash plume over Ecuador. And Nyiragongo now back on video. A stunning aerial video. Okay, we actually showed some aerial videos here. This one from just yesterday. So let's check it out. Side note, Nyiragongo is well known for its having the world's most active and largest lava lake. By the way, follow us on Twitter and maybe follow Nyiragongo Info as well. Let's see if we can find their aerial footage. And there you go. There's some top-notch drone footage there of the caldera. Maybe it's a helicopter. I don't know. I have no idea. But there you go. There's Nyiragongo. Let's continue on. By the way, links to our Twitter page are below the video. And we don't hesitate to remind you on Twitter either to please not pole vault the caldera. No matter how bad things look, never underestimate human resiliency, technology, etc. Civilization's not really ending, folks. So don't pole vault the caldera. It's unwise. Let's get back to space. The GOES magnetometer over the past 3 days, showing fairly smooth readings here. Let's take a look at the heliospheric current sheet, as I'm not aware of what its state is. I'll be finding out at the same moment as you, perhaps. So here's the heliospheric current sheet from the Gong 2 data, the top view ecliptic plane field plot. One of my favorites. And perhaps we'll talk in a different video about what we use this for. But in any case, here is the heliospheric current sheet, and Earth is now in a North Pole current sheet shown here in green, where we expect to be for the foreseeable future. Keep in mind, this magnetic environment can suddenly change. Sunspots pop up, sunspots evaporate quite promptly. So here's the line of sight ecliptic plane field plot. Basically the same data, but from the perspective of Earth instead of from a bird's eye view. And you can see that blue line there being pulled way down towards sunspot 2860. By far the largest sunspot currently visible from Earth. Next, the line of sight coronal hole plot. And you can see some north and south coronal holes showing up there in the imagery. Nothing to write home about. Maybe some not showing up on the imagery as well, but let's move on to the flare probability monitor. And you can see there the high likelihood of major flares. showing as high as about a 30% chance of M-class flare. So that's a very high flare likelihood. And there's the animated imagery there. Sunspot 2859, 2860, and 2861. Possibly another one forming down here in the southwest as well. KP index currently only at 1. And for you new viewers, the KP index is a measurement of global geomagnetism. By the way, if you want to watch what happens on the Earth side of things when a flare occurs, check out the deabsorption region predictions. When a flare happens, you'll see an area light up. So if one happened now, you'd see the area right around there light up, as the area on the Earth that has the sun directly overhead will experience some breakdown in communication. So we monitor this. It's called the deabsorption region predictions. It causes the D layer of the ionosphere to get changed. It causes it to get mitigated by the incoming X-rays, and it causes radio to get blacked out, because instead of being absorbed and re-emitted by the layers of the ionosphere, your radio transmission basically just goes into space. And here's the X-ray monitor from the GOES 16 and 17. The GOES 17 now online, so we'll have additional data in the daily videos. Thank goodness for that. Shout out to NASA. So there's a 3-day chart of the X-ray flares, and you can see some pretty significant C-class flares there, getting sort of close to the M range there, like a mid-C-class range. And keep in mind that is a magnitudinal scale, so each line there, each horizontal line on the scale, represents 10 times the power of the line above it. So this is 10 times A, this is 100 times A, this is 1,000 times A, this is 10,000 times A. Proton flux showing no strikes. No surprises to our channel. We've been forecasting coronal mass ejections for many months, and we've been wrong one time over several months. So here's a real-time solar wind data, and there is a coronal mass ejection currently striking the geospace. So here it is. It's another very weak, diffuse coronal mass ejection. Nothing to write home about, and you can see various different signals here. There's a signal in the BTBZ. There's a phi angle shift at the moment that the coronal mass ejection strikes, along with an increase of the solar wind density and an increase of the solar wind speed. Minor changes in the plasma temperature, nothing to write home about. It's very minor. It's rather uninteresting, honestly. The BTBZ is shifting around again. We'll have to see what happens with that. Current conditions are about 12 protons per cubic centimeter and 420 kilometers per second for the solar wind speed. So here's the geospace, and we have a homogeneous pressure here around planet Earth. A homogeneous pressure there. Very small plasma spheres as well. And according to the space weather modeling framework, the plasma is reaching quite low here. So that's 4 hours of data there. Magnetohydrodynamic pressure modeled in nanopascals. If you want to read about it, click on details on the Geospace Magnetosphere movies. You can read all about the space weather modeling framework there. Here are ground magnetic perturbations. And these are the effects. These are the changes in Earth's own B field caused by the incoming solar protons and all of the different phenomenon that causes. So whether it's the Bremsstrahlung or other aspects of particle forcing, these are the effects to geomagnetism. Those are shown in nanotesla. Here's a diagram of the solar system if you're wondering where stuff is. There's where stuff will be in 7 days. Here's a star chart. We always draw in the ecliptic and the galactic plane. Also the sun not risen yet here in Lehigh Valley, Pennsylvania. Jupiter just about to set, and the moon not too far from its apex. Today's cosmology segment is going to be brief. We're just going to talk briefly about chemical components of the sun. So one of the many things that people have sort of disagreements about when it comes to heliophysics and cosmology in general, astrophysics, is where heavy elements come from. There is one school of thought that all the heavy elements come from supernovae. There's another school of thought that all the heavy elements come from the surfaces of stars, since we see the heavy elements being probably made through things like lattice-confined fusion reactions on and around the surface of stars. and in the stellar coronae. So I'm just brought up this image here because we just wanted to show the corona, the chromosphere, the photosphere, and so on, because chemical abundances are very important when it comes to astrophysics. It gives us some idea of what is happening in things like nebular clouds. So photospheric abundances are one of the many things that are debated when it comes to heliophysics. So I just brought up this paper here, and I'll head up to the title in a minute. I just wanted to display a little bit about this. I just wanted to display a little on this here in terms of observations of what we see in the photosphere, and there's all kinds of chemicals in there, all kinds of chemicals that are kind of strange, and viewing the sunspot is a big deal because there is less interference to muck up the readings. So it's very interesting, the chemical abundances that are on the surfaces and even inside of stars, apparently. So perhaps check out this paper. It's called Solar Elemental Abundances. And that's about all we're going to talk about in today's cosmology segment, as heliophysics is cosmology until we have plausible mainstream concepts of how the sun works. Today's astronomy picture of the day is going to be just shown briefly here. This is one of these cold gas and dust clouds. This one is called Elephant's Trunk and Caravan, and the elephant's trunk is about 20 light years in length, I'm told. And I guess is it this feature? So very large features there, where gas is being swept up and other gas is maybe being eaten up. Who knows? But it is the Elephant's Trunk Nebula, located in the constellation of Cepheus. Go look at it yourself if you like at apod.nasa.gov. That's today's cosmology segment. Let's continue on. No charging hazards currently. So we're seeing pretty low levels of electron flux here. Low levels of electron flux continuing, and no surprises there. There's the one-year chart to put it in context from Solon.info. Here's the 3-day chart of the relativistic electrons. These are measured at the F ionosphere layer by the geosynchronous GOES 16 and GOES 17 satellites. So low levels of electron flux there, nothing to write home about. Here is the relativistic electron forecast, and we're expecting to see a minor uptick here. According to NOAA, at least, I have no argument for that. Here's a diagram of the Van Allen belts. Feel free to pause the video if you like. Here's a total electron content forecast. And we're looking at data from July 22nd for some reason. So let's just ignore that entirely. Here's a diagram of the atmosphere showing electromagnetic penetration and temperature at solar minimum versus solar maximum, and density of molecules in the thermosphere, and so on. Here is the ionospheric map. You're looking at a full day here. We're seeing some low frequency anomalies on the nighttime side of the planet, and some low frequency anomalies on the daytime side of the planet. It looks like less high frequency anomalies, mostly low frequency anomalies. Here's the latest image coming through at 9 o'clock Universal Time. Things looking a little more normal there. Here's the anomaly map. This is departure from the 30-day median in megahertz. And you can see quite a lot of low frequency anomalies shown here in blue. And if you look at the data every day, you might understand the way it corroborates with other data. If you don't, maybe not. Yet another reason to watch our channel. Anyway, there's the current image. Some minor anomalies over places like South America and North Africa. Once again, make sure you check out our playlists. You can find a link to the YouTube channel at smAsho.com. We did a meteorology segment today, once again, and it was pretty epic and pretty important, too. Let's check out the bonus features in the form of the latest intensity gram. And Sunspot 2860 is going berserk. It's going berserk. It's been growing. It's getting lots of additional umbrae there. That sunspot has gotten much more complex just since yesterday. Sunspot 2859 also getting more complex. So it has one major umbra, but then it's got some opposite polarity umbrae trailing it. This is now a beta class sunspot 2. The likelihood of a major flare from that is actually very high. Not sure if that'll be 2861 or 2862 as we are on it. And here's the other one. So all beta class sunspots now. 4 groups on the sun. Just on the Earth-facing portion, a major uptick. Likelihood of solar flares very, very high likelihood of coronal mass ejection. We're at a warning level. That's how high the levels of coronal mass ejection likelihood are. And again, we've been wrong one time over about 6 months. So who knew we could forecast coronal mass ejections? I didn't. I didn't know that I could forecast coronal mass ejections, but as a function of doing these daily videos, I realized that I was forecasting coronal mass ejections, so I thought it might be a good idea to do it. How do I do it? I'm not telling you. I got to write a paper about it. We're a little bit busy here with our website launch, which comes next Wednesday. So make sure you join us for that. We'll have lots of live streams for that next Wednesday. It's going to be a smAsh to OMASH member. Anyway, here's the GOES 16 SUVI imagery. Coronal mass ejection warning, as well as high likelihood of major solar flares. So here's some more imagery. This is 304 and 171 in composite, two of the best wavelengths that you'll find on the SDO, at least in my opinion. Great imagery there of some C-class flares happening yesterday, and we'll show you these wavelengths separately to close out the video. Here's 304 angstroms alone, ionized helium. Great at showing you plasma filaments. And you can see sunspot 2860 getting bigger and more complex. It's going to produce a major flare. Will it be a major flare at Earth? Who knows? We wish there were some X-ray monitors out at Stereo A and B, actually. And shout out to Eugene Bagashov. And congratulations, Mr. Bagashov. I won't divulge why. Maybe you'll have to tell the viewers yourself. Spectacular imagery here. And last but not least, we'll close out the video at 171 angstroms. My personal favorite wavelength. Fantastic imagery of that like explosion, that coronal mass ejection triggered by one of those large C-class flares. Right at that moment right there, you can see actually a wave spreading out over the surface of the sun. Watch the wave propagate. You can clearly see a wave propagating out of that event. So just spectacular. Once again, thanks everybody who tunes in. Tell your friends and foes about the channel. Congratulations on realizing we exist, and may that solar wind be at your back.